Hello developers, let's start developing. So, my name is Veko and today we're taking on the 18th task of the 2024 Advent of Code. And to be honest, this seems like a weird task. So we have a two-dimensional grid, aka a matrix, which ranges in the big example in the actual input from 0 to 70, but in the example from 0 to 6. And we have the following list of byte positions, which are corrupted. So they are becoming corrupted. So once every nanosecond, we get that. So we are faster. We can create a list of all the bytes will fail. And once they fall, we need to find out the path. So first of all, I'm not sure how this connects to everything, because most likely that will be relevant in part 2. But for part 1, we're basically letting the chips fall where they may, and after that, we're going through that. So, seems relatively straightforward that we're just gonna need to find a path through a graph. Anyway, let's start with reading the input. So, first of all, this is our input, and it's gonna be an array of pairs of numbers. So it's not going to be a string array. So, but it's going to be a tuple of two numbers. So that's going to be a number, and we're going to have an array of those. That is our input, which means that each of our lines, we will have to lines.map, split it, and then whatever we split, parse it to an int base 10. And those are our points. We're returning the points, which are the bytes. So let's create a matrix initially. So we will have a Boolean matrix. For now. So we will have our type cell, which is identical to Boolean. So we're gonna fill it with falses. And it's not gonna be 1,000 by 1,000, but it's gonna be 6. Let's just see whether it means 6 or 1 to 6. So it's 7. And now we're just gonna loop through all of our this is the, which one is it? The x and y coordinate, where x is the distance from the left edge, which means it gives us the column, and y is the difference from the row, from the top, which gives us the row. So we have a column index and row index of the input. So then we can say grid of that row index, that column index equals true, and let's print out the grid. And if it's true, we're gonna print a hash. If it's false, we're gonna print a dot. Let's see whether we have something that looks like something. So after all the chips drop, we get a compile error because because we're kind of stupid and we didn't specify that this will have exactly two elements. So we can just say that since we know that this will be a pair of numbers. This is non-trivial for TypeScript to determine because as far as it knows, this might have 2 items and it must have 50 items. We know it has to because we can take a look at the file, but TypeScript cannot. But so now we kind of promised that it's okay, and it says, okay, I can do that. So this is not what we wanted. So we have those, all of them are true. We have only 25 that should be true, and since we have 7, we should have 49, which means less than half of them are true. Yeah, but it says we should only take the first 12. So take from 0 up to the limit. So we only take 12, and let's print it out now. Still, this will be a false thing because we're doing something wrong. This is a boolean. If that is true, I think I know what this is because we are filling that in that way. And this, yeah, matrices and arrays are kind of weird. So we're gonna do it this way. So we're initially filling it with 0, other, and then we're moving it with that. This sounds like it's correct, but it's not. And I should have a special video about that specific weirdness of JavaScript, because I think I know what it's doing, and yep, we got exactly what we wanted to get. If I say that the limit is basically input.length, so we're not slicing anything, we will get something else. Come on. So we got this, and I think I am correct in my assumption. What will be the point of part 2? Because look at this, when the bytes continue falling or corrupting or whatever, we are cut off from the end. So there's just no way to get to the end. So I think that we might need to run through them as they are falling. But first things first, it says the limit is 12. And in this case, we do have a path, and we just need to find that path. And to be honest, finding a path through a maze is kind of easy. So we have our start position. Let's make our grid two-dimensional. Since we're already making here, we're not gonna do this. We're gonna say fill it with false and then map it. Yeah, fill it with 0, and once again map it into an object that will have 2 properties. So it will have the value, which is false, and it will have the price, which is number dot max value, or max safe integer, a huge number. So this is not an array of cells, this is an array of, let's call this a grid cell, or why not, let's call it a cell. So we will have the value, which will be a boolean, and the price, which will be a number, and this looks like a cell thingy. So dot value equals true. So now our printing will need to be a bit different, but basically stays the same. So the price for each of all of them will be the maximum safe integer that is. And now we will just say, let's create a queue, and inside that queue, actually I'm gonna still use a point interface because it makes a bit more sense. X, Y, we might not even need the price. We'll see if we need it. So the queue is an array of points, and initially we can set the grid of 0, 0 to it. Ew, we don't even need to do that. We can just say this, the point 0, 0. And since we're here, we're gonna set the price of the initial start to a 0. So while the queue is not empty, we're gonna take one item out of it. Yeah, we know that it's not empty. The current price for that thingy is that much. We need to find its neighbors. Where did this come from? These are the points that are the neighbors. And we will filter them. Yes, like that. We can use is in bound or something like that as well. But this works as well. So we're filtering the neighbors that are out of bounds, because it's quite possible that they might be. And we're gonna filter the ones that are also walls. Now, true in our case means that it is a wall. So we're not gonna go into our walls. The walls are not our neighbors. The walls are literally walls. And we're gonna add another filter. Only add them if their price is bigger what the price would be. If we do that, do we want to do that? Do we want to set their price? Yeah. When their price is bigger than the current price plus 1. We're gonna set actually their current price to the current price plus 1, and we're gonna add them there. So what does this mean? What will happen? So we have this thing. This has price 0, this has price 1 and 1. And then this will get price 1, price 2, and so on and so forth until we process literally everything. Actually, we don't need to process everything. We can just stop once we reach the destination, but doesn't really matter. So I will say print matrix like that. Yeah. Something along these lines. C is a cell. If C has a value and the value is a boolean, yeah, this was the initial way. So let's just see if this thing actually finishes. It did. So we're gonna print the matrix one more time according to its price. And we're going, yeah, if the value is false, then print it's a val, otherwise print c dot price to string, yeah, something like that. And each val should be double length, so we will get a bit of an expanded view. This is not what we wanted, so we are getting the vals, but a lot of the things are still zeros, or I was hoping to get something better. Let's expand it a bit more, so we might get some spaces, and we actually didn't, only we've gotten bigger walls. No, only that one is 0, so we are not pushing any neighbors inside the queue. Let's see what happens here. It's gonna be actually, let's deconstruct this immediately to x and y, so we can say this is y dot x, that's our current price. It is gonna be 0. And the neighbors are one more, one less, but if we filter them out, we should get 1, 0 and 0, 1. Yep, and we need to filter only those that are false, because we're only taking the vals, and then of course we're not taking the vals. So we're both skipping and unskipping the vals. And now we're getting somewhere. So our first row becomes 0, 1, 2, 3. Oh, and we get this thing here. Note that this is a dot, but it is unreachable, this thing, because there's just no way to get around to it, and it stayed with the maximum value. So let's make this a bit more complicated. So if C price is equal to number dot max safe integer, then print out just a dot, otherwise this is reachable, and print that out. Still doesn't look best, and I've tried to have a really nice looking display, because this helps immensely when you're looking at stuff. And yeah, this is what we want, and we gonna need 21 steps to actually get 22 steps to actually get to that. Let's see, it says that we need to take exactly 22 steps, and there is one such path. Okay, great. So we're gonna change that our response is actually the value of grid with -1 times with -1, and that's the price. So the result for the small input is that. Let's take the huge input. And I kind of hate this, because now in addition to changing the input, we will need to change the parameters. So the width doesn't go from 0 to 6, so it's 7. The width goes from 0 to 70, so it's 71. And the limit of data that is falling is not 12, it's gonna be actually a kilobyte, 1024. So first, I will just run it and hope for the best. It will be relatively fast, and it says that we get to the bottom in 298 steps. Let's see if that is the correct value. And that's the right answer. So what is the part 2? If it is, we need to run as they are dropping. That's gonna be definitely a separate video. Fast enough to make it to the exit before the path is completely gone. The first byte that will cut off the path to the exit. Oh, after the byte at 1-1 falls, there is still a path to the exit. The very next byte, at CX1, there is no longer a path to the exit. Oh! Oh, this is actually much easier. And it's very much doable, and I have an idea of how I will do it, but it's gonna be a separate video. Anyway, don't forget to click like, subscribe, don't touch the bell button, and keep developing.